a jack set, you're talking about the jack rafters and how to calculate the length of the cut going up.
Right.
Okay.
And what I want to do is I want to show how I approach it. Okay, so what you have here is you've got a hip rafter, and you have a bunch of jacks and each jack gets longer as it nails into the hip.
Okay.
So here's how I determine how to cut that. Okay, so I have a certain length from here to the corner. Let's just draw a line from the long point side of that jack rafter. Let's just draw that over to the corner.
Okay.
Okay. Now, if I move that, I can see that that line is, I get a length on it, 2'4" 5/16. Okay. Well,
Okay.
if I wanted to calculate the length of this rafter, and when I talk about length, I'm always talking long point. You see that this rafter has a bevel to it, and it's got a short point and a long point of that bevel. Now, the length of the jack rafter at any given point along this wall is determined by a bunch of different factors. One of them is what the pitch of the roof is. Well, in this case, it's a 4 12.
Okay.
But let's say I had some ceiling joists in here and I wanted to match some ceiling joists. Let's say it was necessary to tie these rafters to a ceiling joist that's going to be coming across here. And by the time I got to the job, let's say that the lumber for the roof assembly wasn't dropped until most of the house was already framed, at least up to the ceiling joist point.
All right.
So it's already joisted, and I have to tie my rafters to a ceiling joist. So what I'll do is I'll pull over whatever dimension I've got from the outside of the building to the ceiling joist if I want to tie on that side of the ceiling joist. And then I subtract the half thickness of my hip times 1.4142. You remember yesterday
Yes.
when we talked? You remember we talked about the square root of 2?
Right, and that's also the secant of 45 degrees, right?
Exactly, but here's why you need to always, you end up using the number 1.4142 so many times it'll become etched in your brain.
Okay.
Okay, 1.4142 times, let's say 1 3/4 inches, 2.47. That's the distance that I have to subtract from this length. Okay, my line here. My first jack, I measured this length. I have to subtract 2.47 inches from that, and then that distance that I ended up with from the point where that edge of the hip intersected the wall to that joist, well, my jack rafter is going to travel the same distance horizontally this way. So I've nailed it. I've nailed the run of my first jack rafter, and then I simply multiply by, in this case, it's a 4 12, so it's a 1.054. How do I know that?
How?
1.054 happens to be, if I take a 4 and 12, 4 divided by 12, and then go tangent to the -1 power, I know that that thing is rising at 18.43 degrees. Okay.
Okay.
Well, if I take cosine of that, and then 1 over x, 1.054. Didn't I call it?
Yeah.
Now, it's not because I'm a genius. I've worked with these numbers so much that I don't need a calculator to come up with that number.
Right.
1.054 is as etched in my brain as 1.4142 is.
Okay.
Okay. It is, just because I've done this for so many years. I don't have to reach for a calculator to come up with the secant of a 4 and 12 pitch. But if I multiply that secant by the horizontal run of the first jack rafter, bingo, I'll have the long point measurement. And let me tell you something about why I use the long point. The long point is a convenient place to hook your tape measure.
Okay.
We could be talking about the center, or we could be talking about the short point, but I always use long points when I'm talking about jack rafters, and it's only because it's convenient.
Okay. And so I have a couple questions. So
Okay.
long point versus short point. The long point is on the top
Nope.
connection. Okay.
Nope. The long point is, you've got a bevel. You got to set your saw at a 45-degree angle to make that cut. See how that jack rafter, let's copy this jack rafter. Let's copy it over here so you can see it without it being on the hip.
Good idea.
Okay, now let's zoom into it. You see how it's got a bevel to it?
Yep.
It's got an angle this way, and it's got an angle that way. This angle this way is done with your saw. You set your saw at a 45-degree angle.
Mm-hmm.
This angle this way is done with your framing square when you mark the line to cut it. And it's done at 18.43 degrees. Basically, you put a stair gauge on your framing square, one at 4 and one at 12, or 2 and 6, as long as it's the same ratio.
And remind me again, 18.43 was the angle of what?
It's the angle of slope of our 4 and 12 pitch.
Okay.
We determined that by taking tangent to the -1 power of 4 divided by 12.
Okay.
Okay. And then we came up with our secant, which is 1.054. And we're going to multiply the actual run. Now we determined the distance from the corner to the joist that we want to tie with.
Right.
And then we subtracted 2.47 inches off that. And the reason we did that was so that we peeled off half this thickness of this hip.
Okay.
Now you got to realize, remember how we got to 2.47. The hip's 1 3/4 inches thick, but we times it by 1.4142, and we got the distance this way.
Horizontally.
I mean, along the wall. And we subtracted that 2.47 from the distance that we measured from the corner to the long point side of the jack rafter.
Okay.
And that gave us the distance that our rafter is going to travel this way, because it's going to go the same distance this way as it is this way. And then we simply took it up. We multiplied it by 1.054. Bingo, we've got our first jack. And now that we know what our first jack is,
Oh my gosh. Okay.
Okay, now that we know what the length of the first one is, we can get all the rest of them. You know
And
why?
that's just because it's a 90-degree right angle triangle. So both the
Right,
sides are the same length.
right.
Okay. Okay.
Okay, so now that we know the length of the first one, we can get all the rest of them. Multiply 1.054 times our 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 in this case they're running in at 2 foot on center. So I
Okay.
multiply that by 24 inches. Bingo. I have a common difference of 25.298. Each successive jack is going to be that much longer than the last one.
Okay. You just blew my mind. That's neat. Okay.
Okay, so I can just simply take my calculator and I can run up a whole line of jacks and I write them down. Each time I hit the equal sign, I'll get another length jack. And then I've got a whole set. Of course, at some point, they're going to exceed the length of the common rafter. And at that point, I know just when to stop.
That was my next question. Thank you. So, okay. So if you could say that again for me. So how do you determine how many jack rafters you need then?
You just keep hitting the button and adding 25.298 inches to that. And then once you get to a certain point, you're longer than you've already figured the length of the common.
Right.
You know what the length of the common, which is way out here. Well, anything longer than the common is too long, and and then you delete that one, and the rest it's what makes up your jack set.
Wow. Okay.
Of course, if you use our service, you don't need to do any of that. You just measure because they're already built for you.
Uh-huh.
I mean, the beauty of getting stuff from us instead of doing it yourself is that you don't have to know any of this. You can just measure the stuff we've already done.
Right. And by the way, everyone, Glenn has been doing this for years, and our website is currently in the works. I'll leave the link down in the description of the video, and you could check that out. I'll have a catalog up of all of Glenn's work so you can check it out. And if you have any interest, you can email us at 3design.inquiries@gmail.com. And again, that'll be in the description down below.